Okay, now I've saved some of the easier ones for last. Let's pop them out. Oh, there's one in the back there too. And this one is I bet you it's a 0.0022. 2200 picofarad. It's another one of these two situations. 002. 2002. Okay, here's the guy we're going to replace him with. I've walked away again. Where did I just cut that from? There's one lead there. Oh boy. I think the other lead is right here. I sure hope the little variation in capacitor size is not going to have a bad effect on this. I mean, the fact is, all these capacitors I'm taking out are nowhere near what they're supposed to be. I'm sure they're all off. They just may not have shorted yet, or turned into little resistors. But their capacitive value would be way off, almost certainly, on all these capacitors. So we heard the radio work a little bit. You know, how much can a little extra microfarad here and there hurt on it? I think some cases they're sizing the capacitor with, basically the cheapest size they can afford to put in. They could put in a bigger, more expensive one, which would be harmless electronically, but would cost them that 0.1 penny. Oh, that didn't work, did it? It would cost them that little bit more. It's interesting. When I touch the soldering iron onto that connection, the speaker hums. It's not very reassuring. So I unplugged the radio from the power. So over you come, right up into there. I did say this was one of the easier ones. I'd say, doing a restoration on a radio like this would really Well, first of all, you wouldn't, I mean, you want to do what I'm doing right now, that's for sure. Got way too much lead length in there. You wouldn't need to, look at all these resistors, they look beautiful. And they aren't, you know, they're manufactured at much higher standards and all that kind of stuff from the, say, the 30s. Or the 1940s even. Where just about everything is suspect today. These particular capacitors I'm doing, these are known problems throughout electronics, not just radios. They work their way into all kinds of stuff. I'm sure that everybody using them thought they were really onto something great. And turned out not so much. Yeah, that's one of the big challenges in engineering is coming up with materials that are going to last decades. Well, they're new materials. You can't spend decades studying them. So you know what they do? They do accelerated life tests. I'm sure you've heard that term. You put them through extra voltage, extra heat, extra vibration, extra whatever. But you know what? It really isn't. I mean, you have to do something, so that's what they do. But that's really akin to taking a 20-year-old, telling him to run quickly around a track for half an hour, and then when he's all tired out, pretending he's now like an 80-year-old and performing tests, thinking you're learning something about 80-year-olds. It just doesn't work that way. And accelerated life testing, exactly the same. So consequently, there's a risk anytime some new thing is introduced into engineering that despite all the attempts, hey, same thing's true with drugs, despite all the attempts to get it right, you may find out that in fact they went way wrong. I think this happened with TV sets in the 90s in North America. Many, many, many TV sets were built. I think they're all built by another company called Thompson or something like that. And after about 5 years of manufacturing, they discovered that their soldering techniques weren't working out very well. And they had a lot of bad connections. Ooh, this is a little tough back in the corner there. He's tucked back in the corner. Oops. I had to move the camera to give me space to get in here. Oh yeah, down there. Pretty tricky now to see what I'm doing. There is another wire down there I do not want to cut. got him. Yeah. And that's a 2200 picofarad capacitor, which is another 0.0022. Wow, it's amazing. You just look away for a moment and it takes me quite a while to reorient, even though this is in a distinct location. It still takes time to get your eyes back to where they need to be. Whoop. Hooked the wrong thing here. Oh, for crying out loud. Very awkward to get in there. Now, how am I going to squeeze that thing down? Let alone solder it. Okay, let's connect up the other end, the easy end. Uh-oh, I cut that too short? No. Okay, let's solder that. There we go. The other end is almost falling into place. Did that move right? Yeah. Yeah, between the camera, the lights, the hot, hot. The tight angle here. Well, I did have another pair of these kinds of long-nosed, needle-nosed pliers. Nice ones with a curve, a little like a hockey stick sort of curve to it. And the surface was, I don't want to say knurled, but it had it's going to have to do, I think. It had a grippy surface, and a friend of mine, years ago, borrowed them these are really meant for just holding things and picking up stuff. They're not really meant for actual work, if you like. And he tried to take a nut off. He was behind his television set or something. And he broke them. Broke the tip right off. Thereby ending decades of great use. I still have them. Here they are. But they're missing the tips. I put them beside my other pliers. You're missing the tips. Yeah, he broke one tip off, and I just broke the other one off to match it. Ah, sad day I still lament about 30 years later. Now let's see if we can get a soldering iron down in there without cooking everything. There it goes. That's not the best connection, and mechanically it's just more like a contact tack connection, but by the time I get the magnifier in there, there's no light left to see anything. Anyway, but it's definitely tight. It's definitely secure. Hey, what are we left with now? Oh, one more. Oh, wait. One more. Can you see it? It's right in front of you. I bet you can't see it. There it is down there. Way down under. Okay, so let's see if we can work our way down to it here. Oh, man. Not a very good situation there. He's way down under. Oh boy.